Good morning, good afternoon, or good evening, depending on where you're tuning in from today. We want to thank you for joining this TechStrong learning experience with Harness. I do have a couple of quick housekeeping notes before we get started. The session is going to be recorded. It will be available on demand afterward, and we will send you a link to the recording once we conclude. We also want to let you know that we have the Q&A panel on the right side of your screen. Any questions that you guys feel like you want to ask throughout the presentation, make sure you put them in the Q&A section. We're going to get to those at the end. And don't wait until the end to put them in there. Put them in at any time. We want to make sure that we have those. We're ready to go. And we've also got the chat, which is right around the same area of the Q&A on the right side of your screen. Go ahead and share your experiences, your comments, your understanding on the matter. We want to hear from you. We want to engage from you. And at least you can do is start off by telling us where you're tuning in from today. And again, share your experiences along the way. Let's go ahead and kick off today's topic. We've got engineering intelligence in the age of AI, from data to actionable insights. And today I'm joined with Adib Valiula, Director and Technical Management Program Manager at Harness. Adib, thank you for joining us. Go ahead and take it away from here.
Hi, everyone, and welcome. I'm really excited to spend this next hour with you talking about a topic that I believe is at the heart of modern software engineering intelligence in the age of AI. What we'll cover today is how engineering organizations can move from just collecting data and staring at dashboards to truly actionable insights that drive real business outcomes. We'll discuss why this shift matters now, how AI is changing the playing field, and how leaders can put in place systems that help teams deliver faster, safer, and more aligned to business goals. By the end of this session, you will have a framework and playbooks you can start applying immediately. But first, let me introduce myself and give you a bit of background. My name is Adib Valiula. I serve as the Director of Technical Program Management at Harness. I'm also a patent inventor, which means I have been fortunate to contribute original ideas to the engineering space. I host a podcast called Metrics That Matter, where I speak with engineering leaders about how they measure what truly matters. I've published 7 research papers on software engineering, developer productivity, and AI-driven insights. Most importantly, my role and passion is helping organizations transform, whether it's speeding up their software delivery, improving developer experience, or aligning engineering more close to business outcomes. At Harness, our mission is to enable the world's 37 million software developers to deliver code quickly, reliably, efficiently, and securely. We think in terms of outcomes. That is faster value delivery, higher stability, lower toil, and tighter alignment with business goals. We build for messy reality, multiple tools, complex pipelines, and teams stretch thin. Everything I'll show you today is geared towards turning SDLC exhaust into engineering intelligence. So teams spend less time fighting and more time shipping value. Let's set the macro context. You can't have a modern engineering conversation without talking about AI. AI is no longer the next big thing. It's already woven into how we ideate, code, test, deploy, and operate. Every conversation I have with engineering leaders include AI, coding assistance, test generation, anomaly detection, policy checks. The question is no longer if you will use AI, but how intelligently you will integrate it so it accelerates value without amplifying risk. This session treats AI as table stakes and focuses on building the delivery system that can keep up with AI accelerated output. And the industry narrative backs this up. Look across statements from Google, Microsoft, Salesforce, Robinhood, and Anthropic. AI is central to their engineering strategy. They're not dabbling, they're operationalizing. The message is very clear. Leaders are already running AI at scale in software delivery. For the rest of us, that raises the bar. We need delivery systems that safely translate AI delivery velocity into value, not regressions, rollbacks, and rework. So, what happens when AI accelerates coding inside a delivery system that hasn't evolved? Data shows AI coding adoption is up by 25%. But in parallel, delivery stability drops and throughput declines. That's the paradox. More code, but slower, riskier delivery. AI doesn't magically fix bottlenecks, it exposes them. If we don't evolve testing, review practices, and governance to match AI's speed, we get more changes stuck in queues and more changes causing incidents. So, where is the time going that is really slowing us down? Only 30 to 40% of developers' week is in the inner loop. That is your planning and coding. The majority, 60 to 70%, is the outer loop, which is testing, security, compliance, deployment, verification, and rollback. That's where velocity gets taxed. This is why we focus on engineering intelligence in the delivery cycle to reduce toil, shrink queues, and get feedback to develop while they are still in context. And that outer loop isn't one step, it's an entire ecosystem. Delivery spans across dozens of workflow, multiple layer of testing, supply chain and app security, change management, infrastructure and database changes, experiments, deployment verifications, rollbacks, cost controls. Each is reasonable, but together they are a maze. Our job isn't to remove complexity, it's to tame it. Intelligence is the map of that maze. Without that map, toil multiplies significantly. Now, too many steps rely on manual scripting, handoffs, unwritten rules, which means toil is repetitive, automatable work that steals time from building value. It's fragile and siloed, so it creates delays and context switching. Developers feel the friction, and leaders feel unpredictability. The fix is not more dashboards, it's closing the feedback loops and standardizing how we see, decide, and act. You can see the toil in four dimensions your executive team cares about. Now, our research suggests velocity around 60% of organizations still release monthly or slower. Cloud spend is rising year over year by 21%. 41% of developers lack automated governance and release to production with risk. 42% admit they cannot deploy without fearing failures. These numbers tell a clear story. Our delivery pipelines are understained. And as AI adds more code, this strain only grows. That brings us to the next wave, the explosion of AI generated code. With coding assistants like Google, Cloud Gemini, Copilot, and others, AI is producing code at an unprecedented volumes. Code volume is skyrocketing. But the guardrails around reviews, testing, compliance, they are not scaling at the same pace. This creates a dangerous imbalance. More code is shipped, but higher risk of vulnerabilities, bugs, and rework. We must evolve delivery systems to keep up with this AI driven output. Otherwise, the delivery problem only compounds. Now, code volume has grown 4x in just a few years in some organizations. Yet, the delivery, as we saw earlier, remains manual, siloed, and insufficient. That means risk scales faster than value. This is the challenge we are here to solve. And this is why engineering intelligence is no longer optional. So, what is engineering intelligence and how does it solve it? Now, engineering intelligence is the missing piece. It's the nervous system of software delivery. It takes raw signals like your commits, your CI/CD data, your incident reports, and transforms them into insights with context, correlation, and closure. Insights that end with an owner and an action. Without this intelligence, we are truly flying blind. With it, we can measure, decide, and continuously improve. So let's define it. It's about enabling engineering transformation. Development leaders need more than charts. They need actionable insight to consistently drive business outcomes. Engineering intelligence gives you three things. First is context. You have normalized data across teams and tools. You have correlations between engineering work and business impact. And then closure around every metrics because it leads to an owner and a decision. That's the leap from dashboards to an operating model. And to stay on track, we use them. We use these as North Star metrics. The first one is efficiency. Efficiency asks how fast teams are building and with what quality. Productivity asks how much work is flowing and connecting developer activity to delivered value. And then alignment asks, are we building the right things? Not just shipping code, but shipping what matters to the business. These three North Star balances the system. If you chase just one, and you will distort the system. But if you balance all three, and you will create a sustainable performance. But balance doesn't happen automatically. You need a metrics program. Now, an engineering metrics program ensures metrics are managed consistently. It involves 5 steps. The first one is you have to decide your objectives. Choose the outcomes your organization values this quarter. Then you create roadmap for each item. Align your teams to those objectives with your organizational goals. Then you select persona-based metrics. Ensure every role sees what's relevant to them. Create an improvement process. Managers file tickets for engineering excellence work so it's visible and prioritized. And then last is the review progress. You regularly meet to track metrics and insights. This turns metrics from passive observation into active management. Now, speaking of personas, let's look at how different stakeholders use these metrics. Different personas need different metrics and insights. Executives care about long-term value creation and business alignment. They want to see velocity trends, change failure rate, risk, and investment profiles. Directors and managers, on the other hand, care about productivity and planning. They look at PR cycle time, unapproved PRs, and whether work is being delivered on time. Now, DevOps and platform leads care about efficiency. They focus on pipeline health, test flakiness, and deployment reliability. Project managers care about execution. They need visibility into epic progress, carryovers, and delivery predictability. One data set, multiple lenses. That's how you drive adoption across your organization. So, how does this model operate end to end? Now, here's how the operating model works. You first integrate, that's the main step when you connect your data sources. It could be your issue management, your source code management, your CI, your CD, and your incidents management. After that, you create your org tree. That is, you create how you want to organize your data. You define the efficiency, productivity, alignment profiles. Then you look into your efficiency, productivity, and alignment dashboards to gain actionable insights into your organization. You convert insights into owners, playbooks, and timelines. And last but not the least, you measure improvement, you rinse, and you repeat. This is a loop of continuous improvement powered by data and not one-off report. And the power comes when we ladder metrics directly to business impact. Now let's connect the dots. When lead time reduces, your capacity goes up, which means your engineering hours are reclaimed. When deployment frequency goes up, you are faster in value delivery and you are deploying in smaller changes. Change failure rate being down means your stability of your platform, your product increases, and your incidents fall. And last one is mean time to restore, which clearly indicates faster recovery and happier customers. Every metric has an operational effect, and every operational effect ties to dollar, risk, or customer outcomes. That's how you make metrics matter to your executives. Now let's take a look at what a good insight actually looks in practice. Here's an example insight card for lead time. Lead time increased by 22% week over week. The bottleneck over here is the PR review time. It rose from 3.6 days to 5.1 days. That's an additional 1.5 days per PR reviewing. So what? What does that mean? Let's do the math. Assuming 50 engineers submit roughly around 2 PRs daily, that is 100 PRs. Now, each pull request waited an extra 1.5 days for its review. That's 150 extra PR days of waiting. Now, if you convert PR days into engineering hours, and if you consider 21 working days, that's around 6.9 engineering months. And at 173 hours per engineering month, that equates to north of 1100 hours. Now, not all of that delay is critical path. If only 25% blocks delivery, that's still north of 300 engineering hours lost in just one sprint. That delay risks slipping your epic by a full week while also increasing developer frustration from context switching. What do we do about this? Which is the now what section. The fixes are pretty clear. First is you want to implement code owners with reviewer SLA of less than 24 hours. You want to encourage smaller PRs under 400 lines of code. Auto merge on green test and deflake the top 10 failing test. Next is deployment frequency. The what over here is deployment frequency dropped 46% month over month from an average of 22 per day down to 12. Now this correlates with pipeline failures doubling from 14% to 28%. So what? Let's calculate the impact. 22 deployments per day times 20 working day gives you roughly 440 deployment baseline. Now at 12 deployments per day, we only shipped around 240. That's 200 fewer deployments. Each deployment typically represents one feature or a bug fix. The release forecast links to around $900 in daily revenue. For an example, let's assume it's $900. 200 deployments times 900 is close to $200,000 of potential revenue delayed. This means slower delivery, delayed features, and competitive risk. In this case, the release of this app completely slipped. Now what? The actions are to assign to DevOps, enable progressive delivery with feature flags, fix the top 3 flaky jobs, and expand parallelism in test suite to reduce your runtime. Finally, let's take a look at change failure rate. Change failure rate rose from 12.5% to 24.2% over the last 2 weeks. The spike was tied to unapproved PRs and large batch merges. So what? If we deployed 100 times at 12.5% failure rate, that's 12 failed deployments. But at 24%, it's 24 failed deployments. That's an additional 12 failed deployments in a sprint. Each failure, if we assume, takes 25 hours to triage, rollback, patch, and redeploy. That's 300 extra engineering hours consumed per week. In practice, The ops team may have reported 200 hours lost weekly. So on top of that, incident doubled from 4 to 8, which correlates to your NPS, which is your net promoter score. Now what? What do we do about this? We enforce mandatory PR approvals, no merges without greater than one reviewers. Apply test impact analysis so only change code paths are validated. Add canaries plus automated rollback to your production deployments. Here's the key: high change failure rate plus long mean time to restore is a costly multiplier. Every extra failed deployment means more time wasted, more risk absorbed, and more money lost. That's why these metrics matter. Now, lead time isn't one metric, it's a collection of stages. By drilling down into PR volume, coding days, your cycle time, review comments, and approvals, you can see exactly where the bottleneck lives. Maybe coding is fine, but review time is slow. Maybe the merges are blocked by flaky test. Drill downs let us move from system to root cause. So the actions are clearly targeted. But even with drill downs, we must use metrics responsibly. Metrics can be dangerous if misused. That's why we set guardrails. You definitely need to have some do's and the don'ts. On the do side, measure at team level, balance efficiency, productivity, and alignment. Use rolling medians, publish those definitions so your organization is aware of what's being tracked. Track deltas and tie to business outcomes. Definitely celebrate experiments along the way. On the other side, do not publish individual scorecards. Use it as a carrot, not as a stick. Change a single metric. Do not chase a single metric. Do not react to week over week noise. Moving goalposts is another don't. You do not want to compare teams unfairly or present vanity metrics without any context. The goal here is improvement, not punishment. Metrics should empower, not erode trust. Next, let's look at how we balance alignment with your organizational goals. So, alignment comes down to investment. How much time is spent keeping the lights on? How much is spent building new features? How much is spent improving existing system? And what about productivity? Healthy organizations set policies. For example, 50% of the work being done should be new work. New work is directly related to revenue generating items, growth items, which is why organizations want to focus 50% of their time in building new stuff. 35% should be keeping the lights on, 15% should be on improvements. And then measure your actual against this policy. Without this visibility, your KTLO can quietly grow and choke out your innovation. With this kind of detail, your leaders can rebalance proactively. Now let's turn common insights into standardized playbooks. Playbooks make insights actionable and repeatable. For efficiency, to improve your lead time, you want to decompose, you want to optimize your CI, you want to parallelize test and use progressive deliveries. To increase your deployment frequency, you want to deploy in smaller batches, automate those pipelines, decouple deploy from release. To reduce your change failure rate, you want to contract those tests, enforce approvals, monitor error budgets, stage those rollouts. And lastly, to reduce your mean time to restore, you need to have a rollback playbook. Automate the rollbacks. Invest in chaos testing so you shift left your testing. Observability. Use feature flags so you don't have to roll it to the larger audience, only to realize you have to roll it back from them. For productivity, if your PR velocity is suffering, you want to split your epics. Maybe your epics are large enough. Enforce work in progress limits. If your PR cycle time is suffering, review those SLAs. Make sure there are smaller pull requests. Make sure there are auto merges on greens. If low work is being completed from your development team, then you need to invest in better planning. Enforce that definition of done so your team is clearly understanding what work is cut out for them. Low coding days, reduce meetings. A lot of the time developers spend on meeting can be avoided, which directly affects coding days. Automate that toil. Enable self-service. Have an internal developer portal which would help your developer not only with day one but day two activities. So how do we roll this out without boiling the ocean? Let's take a look at a 90-day implementation path. Here's the roadmap. The first couple of weeks, you want to connect to your sources where the data comes from. Issue management, source code management, your CI/CD, your ITSM. Create your org tree structure, validate your structure. How do you want to organize your data? In the following weeks, you want to set some baseline, agree on some definitions, publish some targets for your teams to go achieve. Moving forward in that week, you want to pilot with one or two teams, run these 3 playbooks, show the deltas. In the later stage, you want to scale this organization wide. Automate insights to action workflows. Institutionalize the cadence. Engineering metrics program plays a very important role here. By the end of 90 days, you have not only proven value, you have created a sustainable improvement rhythm. And this isn't theoretical. We have seen it work across industries. Let's take a look at a few industries. In the cybersecurity world, unapproved PRs dropped 32%. PR cycle time, on the other hand, improved by 98%. That accelerated feature delivery for this organization. For a company in the information technology industry, PR cycle time shrank from days to minutes. Deployment frequency jumped to a dozen per day, massively improving their throughput. One other such example was in banking and finance industry, where this organization's lead time was reduced by a whooping 78%. That means their time to market significantly improved, significantly helping them with their competitive advantage and boosting their predictability. Now, these are real organizations, real data, and real impact. Proof that engineering intelligence delivers concrete results. When you club this with engineering metrics program, your persona based metrics, defining that objective, this helps you achieve greater success. So, how do you keep this momentum going quarter after quarter? Sustainable excellence comes from rhythm. Like I mentioned, engineering metrics program is the core to track these trends. Have those monthly retro on these playbooks to refine what's working, to see where we need to spend some time, where we can improve, and learn from those things which have worked well for your organization. Quarterly resets to align metrics with business priorities. All of this is wrapped in the loop. Insights, action, outcome, and learn. That loop turns intelligence from a project into a habit. And when it becomes a habit, you stop running on intuition and start running on insights. Let me close by thanking you and pointing you to a few resources. I really appreciate you joining today. If you would like to continue this conversation, I would love to connect. I do share more on these topics through my podcast Metrics That Matter on Apple and Spotify, and through LinkedIn and Medium, where I publish case studies, frameworks, publications, and lesson learned from the field. Engineering intelligence is a journey, not a destination. And my hope is that today it gave you both the urgency and the tools to take the next steps. Now let's open it up for some questions.
All right, Adib. So we do have a few questions. The first one is, how is engineering intelligence different from traditional dashboards and reporting?
Yeah, dashboard give you visibility, but they stop at observation. Engineering intelligence goes further. It provides context, correlation, and closure. That means every metric is tied to a business outcome and ends with an owner and an action. So instead of what happened, you also get so what and now what. It's the difference between a weather report and an umbrella in your hand when it rains.
All right. The next question is, isn't there a risk of metrics being misused and creating a surveillance culture?
That's a great question. So absolutely, and that's why we stress on those guardrails. We don't measure individuals, we measure teams. And we do not chase a single metric. We balance efficiency, productivity, and alignment. And we use deltas to spot trend. We take a look at those drill downs, understand those smoke signals. And I say this to all of my audience, metrics are there to empower teams to improve, not to punish them. Use it to start a conversation to understand what's happening so you can get to the bottom of it.
All right. So how does AI change the way we should think about delivery metrics?
Yeah. Um, so AI accelerates your code creation, but it doesn't really accelerate delivery by itself, right? You get 4x the amount of code by using coding assistant, but your delivery cannot scale with it. It can overwhelm your pipelines if you don't adjust. That's why metrics like lead time, deployment frequency, your change failure rate, and mean time to restore are more important than ever. They help you see where the pipeline is breaking under that AI driven volume and gives you a playbook to fix it.
And this is the last question I've got. So if anyone has any more questions while we get this answer going, feel free to put those in the Q&A section. We'd love to hear from you. What is the fastest way for an organization to get started with SEI?
Mm-hmm. So, in my humble opinion, start small and time box it. Pick one or two teams, baseline their efficiency, productivity, and alignment metrics. Run these programs, these playbooks over a 90-day cycle. And at the end of it, you'll have a clear before and after data and a repeatable process. Now, engineering metrics program and defining your persona based metrics will be key to getting started with SEI. And look at your organizational objectives. Where are those pain points today? Pain points for one organization are very different than the other. So comparing is not the best solution here. Pick a few areas where you feel there's an opportunity for the teams to level up. Focus on those core set of metrics, measure the impact based on the changes you did, and then rinse and repeat. That's the best way to get started with SEI. The goal is to prove value quickly, not to boil the ocean.
All right, Adib, unless you have any more final thoughts or key takeaways that you want to add in, I think we can go ahead and get started to close out.
Yeah, I mean, again, thank you to the audience for giving me the opportunity to share my journey, share some insights around software engineering insights, how engineering intelligence is helping organizations. The key takeaway is to focus on your organizational objectives, create engineering metrics program, have a regular cadence, measure the impact, rinse and repeat. Use it as a carrot, not as a stick. Focus on those core problem areas your organization is suffering. Go tackle it in the next quarter and rinse and repeat. That's the best way any organization can transform and can get onto the continuous improvement journey. Thank you so much for everybody for joining today.
All right, Adib, thank you for taking the time to join us today. It's been a pleasure, and I want to thank all of you that stuck around through the entirety of this presentation. I do want to remind everyone before we close out, this session is recorded. You will receive a link in your inbox shortly after we conclude. And also, if you haven't yet, go ahead and click the survey in the resource section on the left side of your screen. It's 4 quick questions. It does go a long way. We'd love to hear from you. Share your thoughts. Share with us how we can improve and what you want to hear on the next webinar. And on that, we look forward to seeing you on the next Tech Strong Learning webinar. Have a great day, everyone.